Hello everybody, welcome to this game programming tutorial in C++. Today, we're going to create the gameplay for our game, which is going to be Pong, as well as adding collision and a barrier movement. Hopefully you are caught up with the series and did last tutorial's challenge, but if you're not, you can watch all of the previous tutorials by going to the link in the description. So let's get started. Mega Man Lego commented on last tutorial a small problem that is happening. Let me quickly go back to the movement when I only press the button. See that it's working? But what happens when I hold the key? Note that I had a single initial movement, then I have constant movements? Similar to what happens when I type on Notepad, for instance. This is because the WM key down message is called multiple times, even when the key hasn't been released. And that's configurable by the user in the OS. So how can we do to avoid it? If you remember from last tutorial, it is the changed variable that gives us the information about the pressed or released state, and it is being set to true every time we receive the message. What we really want to do is set it to true only if the current is down is different from the recorded is down. That way, we only set changed if the is down really changed, no matter how many times the OS calls this message. Fixed. Now let's start making the gameplay. The first thing I'll do is to add some rectangles to the scene so that it starts to look like Pong. I'll add the 2 players, the ball, and an arena to let the player know where the game and the collisions will take place. We can add some movement to the player like we did last time. But see that the movement is linear? We just add a speed to the player when the button is down, and that doesn't feel good to control. In order to improve the game's feel, we're going to add a more complete movement equation that contains acceleration, friction, and all that. This is where game physics come into play. Now let's learn about the equations of motion so that we can make our player movement feel great. Previously, we added a position variable that incremented every frame by a velocity amount. The velocity is the rate of change of position in time, so we can call that the derivative of the position. What we want to do is to make the velocity have its own variation in time, so that it picks up speed over time. So the derivative of the velocity will be the acceleration, which is the rate of change of velocity in time. So when the player presses the move button, instead of changing the velocity, we'll change the acceleration. And since the acceleration is the change of velocity over time, we can easily calculate the new velocity by adding the old velocity to the acceleration times the delta time, pretty much like we were doing before. And now for the position. Since we are considering both first and second derivatives, the velocity and the acceleration, our equation has to consider them both. So the new position will be the old position, plus the velocity times the delta time, like we did before, since it's the first derivative, plus the acceleration times the delta times squared, divided by 2. If you want to know where this equation comes from, you can watch some calculus lessons online. Khan Academy has great videos on that. Now let's program that. I have to store the velocity across frames, just like we did the position. And I'll call that dp, since it's the derivative of the position like we discussed. The acceleration, called ddp, since it's the derivative of the position. I'll create every frame, because I want to accelerate the player in the frame the key is being held. So if it's down, I'll add acceleration. Now all I have to do is to add those 2 equations we discussed. The equation for p, considering both derivatives, and for the velocity. And look at that! We already have nice and smooth acceleration. But it feels like we're floating in space because we have no friction. The friction will be a change in the acceleration, and it will be based on the velocity. That's simple. Those values we can tweak to get the game exactly how we want. Maybe more Super Meat Boy-like, or maybe more like Mario. Now we have an awesome movement. That feels really nice to control. Well done. And with that done, I'll quickly copy that to the second player. The next tutorial, we're going to add an AI to play against that, but for now, I'll control both players. I'll have to add more keys on the platform layer, but you should be familiar with that already. Now there's a problem. Our player goes straight through the wall. We have to make it collide with it. So let's learn about collision detection. Game physics is a great topic on its own, so we'll learn the introduction to collision detection so we can start making our game actually work. The basic idea is, we want to move the player to here, but we need to know if that move is valid or not. So we have the player position, as well as the player half size. We also have the size of the arena. So all I have to do is to see if the player position plus its half size, which is this point, is greater than the arena. That's simple. This collision detection is a 1D collision, because it only considers one axis. Let's program that. I'll just make the arena half size a variable. If the player P plus the half size, and I'm going to add that as a variable, is greater than the arena Y, we are colliding. What will we do when we collide? First, we need to move the player back, so it's not colliding with the wall anymore. All I have to do is to set the P to the arena minus the player half size. That'll move it back to the limit. We can also change the velocity, because we abruptly stopped the player. Now let's see the result. Awesome, right? We can also set the velocity to different values, like inverting it, so the player will bounce in the opposite direction. Pretty cool. We can also make that value larger, so the player is repelled from the wall. Yeah. I think the best thing to do in this case is just to set it to 0. Now let's do that to the other wall. It'll be the same thing, but inverted. And to the other player as well. Great, our players are done. Now let's move the ball. For the ball, I'm not going to add an acceleration because it makes it harder to predict. So the ball will just linearly float around the arena, not losing or gaining much energy. But I will set an initial velocity. And add the position equation with the first derivative. And that's moving alright, but not colliding. So for the ball, we'll have to do a more complicated collision, one that will consider both shapes' sizes and the x and y axes. This shape is called an AABB, which stands for axis-aligned bounding box. It's simply a box that is not rotated. It's aligned to the coordinate axes. So we want to test an AABB versus an AABB collision. It's the same idea we did last time. If the rightmost point of this guy is greater than the leftmost point of this guy, we have a collision. But we should also have to consider the other axes. See? So this has to be done in all 4 directions. Let's jump to the code and it'll be clear. Let's first add a collision with the ball's right side. So ball P plus the ball half size, and I'll make a variable out of that as well. With the player's left side. When we are colliding, I'll set the ball P to the limit position like we did before, and invert the x velocity. So now it'll move the other way. Great! But if I move the paddle out of the way, see that it's still colliding? We have to test the other directions as well. So it will only be colliding if you are penetrating the positive x, the negative x, the positive y, and the negative y. Let's see. Perfect. That's an AABB versus AABB collision. Let's just do the same thing with the other player. We almost have a game. The problem that we have no way to change the direction the ball is going. Usually these games either change the direction of the ball's velocity based on where it hit the player, so that if I hit the very top, the ball will go up and so on, or change it based on the player's own velocity. Let's try them both. When the player collides with the ball, I'll set the ball dpy to the player dp. This way, if the player hits the ball going up really fast, for instance, the ball will also go up. That's awesome. We can also add a coefficient to that, like 0.75. Great. The other option is to make the ball go up or down based on where it hit the player. Do you think you can implement that? If you want this challenge, pause the video and try to do it yourself. Okay? So if we subtract the ball position with the player position, we have a value that shows how much up or down the ball is from the center of the player. We can just use this value directly. So I'll set the ball dpy to the subtraction. And that's great. It's a bit subtle though. We can just multiply that by 2, for instance. Awesome. If we wanted, we can make both these factors influence the ball, see? It's awesome to play around with this and get the exact feel we want for this game, so play around with it for a bit. Now there's the obvious problem of the ball collision with the arena top and bottom. Want to try that yourself? Pause the video and give it a go. Okay, it's really easy. If the ball py plus the ball half size is greater than the arena y, set the position to the limit and invert the velocity. That's it. Same thing for the bottom, but inverted. Let's see. That's it. We have our base gameplay. Awesome, right? Let's quickly add the collision with the arena left and right and reset the ball when that happens. Want to try that yourself? Pause the video. Okay, let's go. It'll be the same thing but for the x-axis. And if you collide, I'll invert the x so it goes toward the other player. I'll zero the dpy and reset the position to 0. Same thing for the other player. Now you see that here's where we're going to add the score, right? Let's play it for a bit. Oh man, that's so cool. Making games is awesome. Before we call that a day, let's clean up the code, because we quickly added a lot of features and left a mess behind. But it was great, because now we know exactly what we have to do for the game, since it's already written in front of us, and it's super easy to see where we have duplicated code, for instance. If you want to know more about the style of solving the problem first, and then worrying about creating a nice and clean structure for the solution, search for semantic compression. It's really awesome. So this player movement thing happens the exact same way for both players. So I'll just create a simulate player function that receives the player P, dp, and ddp, and the delta time. And since we want to change the value of the position and the velocity, I'll get those as pointers. Check out this video if you want to learn more about pointers. I'll just paste the code inside here and change the parameters, and use the value the pointer is pointing at by using the asterisk before the variable, instead of using the memory address the pointer holds. Now by calling this function for both players, we got that really organized, right? Looks great. Let's see if we break anything. Oh, it's working great. Another thing we can compress here in the code is the AABB collision test. This if here. I'll copy that and make an AABB versus AABB function that returns a boolean, whether collided or not. It'll just be the if. I have to receive everything as parameters and call that whenever I need to. Cool. I'm gonna put the rendering down here. Now I could make this whole thing a simulate ball function, but since we only have one ball, we probably don't want to pass tons of parameters. I'll do what John Carmack, the creator of the original Doom, suggested, and compress it by just adding a scope here and commenting. We don't add unnecessary functions to the game, functions that will only be called from one place, and we can do the whole thing here in line. No need for globals or parameters. And if I want to get this code out of the way, I can just click this little minus box here. Nice. Well, the next thing to do will be the score system. I'll leave that as a challenge for you to program before the next tutorial. You can start by just implementing the score counter, and then adding a way for the player to see the score. That'll be a nice challenge. I hope you enjoyed this tutorial. If you have any questions, be sure to tell me in the comments. If you liked it, please click the thumbs up and share with friends, it helps a lot. Next time, we'll finish the gameplay by adding an AI to control the enemy. That'll be pretty cool. I hope to see you then. Bye!